You're listening to DTF for May 10th, 2026. I'm your structurally unsound host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where people who build things argue with people who describe things. Today's got that restless energy where everything old looks new and everything new looks suspicious. Let's get into it. There's a number buried in this blog post that most readers scrolled past. 10 euros. The example payment is 10 euros. Then the second request comes in with the same idempotency key. But for 100 euros, same key, different amount, that tenfold difference is where the entire concept of idempotency cracks open. Most engineering teams treat idempotency like waterproofing a basement. Slap on a membrane, install a sump pump, done. But waterproofing assumes water always behaves like water. What happens when the second flood is oil, same basement, same drain, completely different physics? The article lays out a taxonomy that's worth paying attention to. A completed replay. Find, return the cached result, a concurrent retry, where the second request arrives while the first is still processing. Now your idempotency layer is also your concurrency control, a partial local success where the payment row exists, but the event never published. A downstream unknown, where the payment provider accepted the charge, but your process died before recording it. Each of these is a distinct failure mode, and a simple replay cache handles exactly one of them. The author makes a precise distinction that matters. Idempotency is about effect, not about response. HTTP gives you method-level semantics. A put can be naturally idempotent, a delete on something already deleted. The resource is still gone. The effect is the same, even if the status code changes. But POST requires explicit machinery, and that machinery has to account for audit logs, domain events, emails, provider calls, billing metrics. Every side effect the business actually cares about. One of the commenters pushes back, arguing that half the problems described are really atomicity problems, not idempotency problems. And they're right, in the way that saying half of structural engineering is really gravity is right. The observation is technically correct and practically useless. In production, these concerns are fused together. Your idempotency layer inherits every atomicity problem your system already has. The real contribution here is the checklist at the end. Retry after expiry, retry after a deploy, retry after a schema change, retry after a region failover. These are the cases that surface at 3 a.m., and they're the cases that a demo-ready implementation never encounters. This is the kind of careful, experience-driven systems thinking that makes distributed systems actually work. The code is open, the patterns are documented, the failure modes are named. That's how knowledge compounds. Someone names the failure mode precisely enough that the next engineer recognizes it before it costs them a weekend. And when it comes to naming what works, Bun just put a number on it. Pause 99.8% test compatibility from a full Rust rewrite on Linux. 960,000 lines of code. 6 days. Let me tell you why those numbers are funny. In Darren Decterls, with that programmer could produce about 10 debugged lines of code per day. That number held remarkably stable for decades. Brad Brooks cited it in the mythical Man Month in 1975, and it was still roughly true in 1995. The industry's response was not to make programmers faster. It was to make the lines do more. Higher-level languages, better abstractions, richer standard libraries. The constraint was always human cognition. How much complexity one mind can hold at once. Jared Sumner just mass-converted Bun from Zig to Rust in 6 days and hit 99.8% test compatibility on Linux. At the old IBM rate, this would take 263 years of solo programming. Even with a large team writing 1,000 lines per day each, You're talking years of coordinated effort. He did it in less than a week with AI assistance. Now here's the comedy. The Hacker News thread exploded with 300 comments debating code that, by the maintainer's own admission, wasn't finished yet. People arguing about whether AI-generated Rust is idiomatic, whether the test suite actually proves anything, whether this is vaporware. All before the branch was even merged. The Internet's immune response to change is faster than the change itself. But the substantive point buried in the comments is correct and worth pulling out. This worked because Bun already had an extraordinarily comprehensive test suite. The AI didn't validate its own work. Humans wrote those tests over years of careful engineering. The tests are the specification. The AI is the translator. Without the first, the second is useless. With both, you get something that looks like time travel. The language choice itself matters. Bun's codebase had a reputation for crashes and memory bugs. Rust's ownership model eliminates entire categories of those failures at compile time. This isn't just a rewrite for rewrite's sake. It's a safety upgrade that would have taken 10 years to execute manually and therefore would never have happened. The constraint just changed. For 30 years, the bottleneck was human typing speed and cognitive load. Now the bottleneck is having a good enough test suite to validate machine output. The teams that invested in testing infrastructure just discovered they were building something more valuable than they knew. A specification precise enough to guide automated translation. The tools exist. The leverage is real. And it favors the teams that did the unglamorous work of writing tests first. Moving on. In 1988, Robert Morris launched a worm across the early internet. It wasn't sophisticated. It exploited known vulnerabilities that any competent sysadmin could have patched. But it worked, spectacularly, because almost nobody was watching. The assumption was that small-scale nuisances weren't worth defending against. The architecture of trust was calibrated for serious threats, and anything beneath that threshold moved freely. 50 years earlier, a retired junk collector named Emmerich Jutner discovered the same principle in analog form. Jutner's counterfeit $1 bills were by any technical standard awful. Wrong paper, bad ink, blurred engraving. Some had spelling errors. He produced them on a cheap hand press in his apartment kitchen using zinc plates and rudimentary photography. A banker would have spotted them instantly. But Jutner never handed one to a banker. He handed them to bartenders during rush hour, to street vendors making change, to diner cashiers processing a lunch crowd. He understood something elegant about the security model of American currency. Scrutiny scales with the domination. People hold 20s to the light. Nobody interrogates a dollar bill. The authentication check exists, but it's never triggered at the bottom of the value stack. This is where the engineering gets genuinely clever. Jutner rate-limited himself. A few bills a week, scattered across different neighborhoods. Never enough to create a pattern. He wasn't trying to get rich. He was trying to eat. And that modesty was his best camouflage. The Secret Service opened case number 880 and spent a decade chasing their longest and most expensive counterfeiting investigation. Because every tool they had was designed to catch operations optimized for scale and profit. Jutner optimized for neither. Pull this thread into any security system and the lesson holds. The most dangerous exploit isn't the sophisticated one. It's the one that operates below the detection threshold, the one that looks like noise. Every authentication architecture has a floor beneath which verification becomes optional. And that flaw is a design choice with consequences. Gesner was eventually caught in 1948 when his building caught fire and firefighters found his plates. Not tradecraft failure, not pattern detection. A literal accident. He was 62, living alone, counterfeiting just enough to survive. The judge fined him $1. One commenter wondered whether the cashier checked the bill. The system caught him by chance, not by design. That should make every architect a little uncomfortable. Moving on. What does it actually mean to build something from nothing? Not nothing as in no funding, no team, no runway. Nothing as in no standard library, no libc, no abstraction layer between your intentions and the kernel. Just you, writing ARM64 instructions by hand, talking directly to the operating system through syscalls, asking it to open sockets, fork processes, read bytes off the wire. That's what Umaki is, a fully functional web server written entirely in ARM64 assembly for Apple Silicon. It handles get, put, delete, options, head. It does MIME type detection. It supports range requests, which means you can scrub through video served by handwritten assembly. It decodes %encoded URLs. It blocks path traversal attack. Catches the double dot tricks while still letting you name a file. Oh, well, tricked. Put requests are atomic, writing to a temp file, then renaming, so concurrent uploads don't leave partial garbage on disk. There's slow LoRa's protection. This isn't a toy. This is a real server with real defensive engineering, built at the lowest level a user space program can operate. Let's break this down to first principles. What does a web server actually need to do? Bind a socket, listen, accept connections, fork a handler, read an HTTP request, parse it, map it to a file, open that file, read it, write a response with the right headers, close everything. That's it. Every web server framework in existence is an abstraction over exactly these syscalls. Ngengad dot, agot d. They just do it through layers of C, through libc, through allocation, strategies and configuration parsers, and module systems. Waimaki strips all of that away and does it in the language the CPU actually speaks. The comments on this one are worth reading. There's genuine warmth, people remembering what it felt like to be challenged by a machine, to write code where every register matters, where you can't hide behind a garbage collector or a type system. One commenter is building a software renderer in raw WebAssembly for the same reason. Another points out that once you get deep enough into macro assembly, it starts feeling less alien than you'd expect. More verbose, but structurally familiar. That's the thing about first principles. When you strip away the abstractions, you don't find chaos underneath. You find clarity. The machine is simple. The complexity lives in the layers we built on top. And sometimes the most illuminating thing an engineer can do is peel those layers back, one by one, until there's nothing left but instructions and intention. The source is on GitHub. Every line of it. That matters. This isn't just craft for craft's sake. It's craft you can study, fork, learn from, the blueprint. The whole architecture is right there. Someone wondering how sockets actually work at the hardware level now has a reference implementation written by a human being who clearly enjoyed every minute of it. That's how knowledge compounds. One person's curiosity becomes everyone's curriculum. We talked about understanding coming from building. Pause now, let's flip that. Sometimes we see something work, and then the understanding clicks. One commenter on this piece called it the myth of the brain. Namita du cerveau. Something they notice in French engineering school. The idea that if you're smart enough and you think hard enough, the answer will just appear. Another commenter pointed out that repairing things as a kid was the perfect antidote. You had to build a mental model, test it against reality, and adjust when reality pushed back. The comment section is full of engineers nodding along, recognizing a pattern they've lived but never had a clean name for. Daniel Lemire calls it thinkism, a term he borrows from Kevin Kelly, the belief that progress flows from understanding, that you think first, then build. That theory precedes practice, and he argues, convincingly, that history runs the other direction. We built pendulum clocks in 1416. Newton formalized mechanics a decade later. The doing came first, the understanding followed. This matters beyond philosophy of science. This is about who gets to participate in progress. If you believe breakthroughs require complete theoretical understanding before anyone touches a keyboard, you've just locked out every autodidact, every tinkerer, every self-taught developer who learned by shipping broken code and fixing it at 2 in the morning. Thinkism is a gatekeeping mechanism, whether it intends to be or not. It says you need the degree, the design document, the committee approval before you're allowed to try. It's the waterfall model applied to human potential. The open source movement understood this instinctively. You don't wait for a complete specification. You ship something that works, you put it where people can see it, and the understanding crystallizes through collective iteration. Linux wasn't designed in a university lab. It was a finished student's experiment that worked, and then thousands of people helped everyone understand why. Lemire makes a pointed observation about AI too. He warns against expecting that an AI system that can read all of human scholarship and think for a long time will automatically produce breakthroughs. Knowledge isn't enough. The world is too complex, and too much of what we think we know is slightly wrong. We just don't know which parts. The breakthroughs come from trying things, observing what works, and then, only then, building the theory to explain it. The recipe is simple. Build more. Observe more. Put your tools where other people can reach them. The understanding will come. Moving on. $1,000 for a calculator that does exactly what a $15 Casio from the drugstore does. Addition, subtraction, square roots, the usual. Same buttons, same functions, same answers. You're not buying computation. You're buying Urushi lacquer applied by hand in a process that takes months. A display engineered to be readable at angles nobody will ever use. And key switches tuned to a tactile response that most people couldn't distinguish from the cheap version in a blind test. And I want one. That's the part that's hard to admit. Let me play devil's advocate for a second. The rational case against this thing is airtight. It's a vanity object. It's conspicuous consumption wrapped in craft mythology. For $1,000, you could buy 66 regular calculators and tile your bathroom with them. The utility delta is 0. One commenter on this put it perfectly. They called themselves a Philistine, said they wouldn't notice any difference from glossy plastic, and they're probably right. Most of us wouldn't. But here's where the rational case falls apart, because the point was never the calculation. The point is that someone at Casio decided a calculator deserved the same treatment as a Stradivarius. Japanese lacquer work. Yorose is a technique that predates industrial manufacturing by centuries. Applying it to a desktop calculator is either the most beautiful or the most absurd act of craft preservation imaginable, and I think it might be both. What actually interests me is what this says about manufacturing culture. Casio didn't outsource this to a luxury brand. They didn't slap a leather case on a standard unit and call it premium. They went deep into material science and traditional craft and made something that's genuinely unnecessary and genuinely excellent. One commenter nailed it. They have no use for this thing, but the product page alone closed the sale. There's a lesson in builder culture here that has nothing to do with calculators. The best things get made when someone cares past the point of economic rationality. When the craft itself becomes the product. Most of what we build in software, in open source especially, lives in that same irrational space. Nobody needed another text editor. Nobody needed another Linux distribution. But someone cared enough to make it anyway, and sometimes that's exactly how the best tools arrive. A $1,000 calculator won't change your math. But the impulse that created it, that's worth understanding. Moving on. Let me make the case for Google here. Multimodal RAG is hard. Genuinely hard. Getting a system to understand that a photograph of a whiteboard, a PDF diagram, and a natural language query all relate to the same concept requires serious engineering. Google has the embedding models, the infrastructure, the talent, and they're offering this through an API that any developer can call. Paid citations for grounding, custom metadata, native image understanding without OCR hacks. If you're building a production application today and you need this to work by Friday, this is probably your best option. Now run this forward 5 years. Your entire visual archive lives in Google's infrastructure, your company's internal documents, your medical images, your creative assets, your proprietary research. All indexed by Google's embedding model, stored in Google's vector database, queryable only through Google's API. The retrieval layer becomes the dependency you cannot remove. Your application doesn't function without their endpoint. Your data doesn't move without their export tool, assuming one exists. The switching cost compounds quarterly. The comments are revealing in a specific way. One user points out that Google, the company that built its empire on search, ships AI products where you cannot search your own conversation history. You can only search titles. The world's most sophisticated information retrieval company won't let you retrieve your own information effectively inside their own product. That's not incompetence. That's architecture revealing priorities. Another commenter asks the question that matters. How much would you pay to run this locally, GDPR and HIPAA compliant, without subscriptions? The answer increasingly is that you can. Open embedding models exist. Open vector databases exist. The gap between what Google announced today and what you can self-host narrows every quarter. The capability is real. Multimodal embeddings that understand visual semantics alongside text is a genuine technical achievement. But capability, delivered exclusively as a managed service, is capability with an expiration date attached. One you don't control. The interesting development isn't that Google built multimodal RAG. It's that the open alternatives are close enough that the lock-in calculus has changed. 5 years ago, you had no choice. Today, you have a choice. 5 years from now, choosing the proprietary path will require active justification rather than passive default. The tools exist. The question is whether you're renting them or owning them. Moving on. I've built distributed systems, not at the scale of civilizational memory, but enough to know the first rule. A single point of failure is a single point of control, and a single point of control is eventually a single point of loss. The Internet Archive just opened a foundation in Switzerland, St. Gallen specifically, a city that has been in the archiving business for 1,000 years, back when archiving meant monks hand-copying manuscripts onto vellum and hoping the building didn't burn down. The monastery library there still exists. 1,000 years of continuous operation. Run that forward and ask yourself what digital institution today could make the same claim. The architecture of this matters more than the announcement. Internet Archive Canada, Internet Archive Europe, now Internet Archive Switzerland. Independent organizations, mission-aligned, distributed across jurisdictions. If you've ever designed a system that needs to survive node failure, you recognize this pattern immediately. It's replication. It's the same principle that makes RAID work, that makes distributed databases work, that makes the internet itself work. You don't protect data by building a bigger vault. You protect data by putting copies in places where no single authority can reach all of them at once. And the timing is pointed. The Internet Archive has spent the last few years getting sued, getting DDoSed, getting dragged through courts by publishers who treat access as a threat to revenue. Consolidation makes you a target. Distribution makes you resilient. The Swiss Foundation isn't just expansion. It's a fault tolerance upgrade. They're also archiving AI models, which is the kind of quietly radical decision that won't get enough attention. Every major AI lab is training on the public record while treating their own weights as trade secrets. Someone needs to be capturing what these systems actually are. Right now, before the next generation overwrites them, and we lose the ability to audit what happened. The University of St. Gallen partnership on this is exactly how it should work. Academic infrastructure preserving technical artifacts that corporations have every incentive to disappear. One commenter noted they couldn't find any actual archived content on the new site yet. Fair, but the monks of St. Gallen didn't start with a full library either. They started with the decision that remembering mattered. The infrastructure comes after the commitment. Now for something completely different, from preserving the web's memory to fighting one of its oldest annoyances. Pause query strings. 414, that's the HTTP status code Chris Morgan's server now returns if you add a query string to any URL on his site. URI too long. He chose it, and I quote, because it's funnier this way. But here's the detail worth noticing. He doesn't use any query strings. Not one. His entire site operates without them, which means every single query parameter attached to his URLs was put there by someone else. Referral trackers, UTM campaign tags, analytics breadcrumbs. None of it his, all of it writing on his domain, like bumper stickers he never asked for. The question nobody in the comments seemed willing to ask directly. Whose URL is it, actually? Because the entire tracking parameter ecosystem assumes an answer. It assumes the URL is a shared surface. That if I link to your site, I get to modify the address to serve my analytics. UTM parameters were literally designed for the linker to track their own campaigns using your domain as the canvas. And we've all just accepted this as normal. Every newsletter, every social share, every aggregator appends their little signature to someone else's address. What Morgan did is mass trivial. A few lines of server configuration. Reject any request that includes a question mark where none belongs. The engineering is almost comically simple, but the assertion it makes is genuinely interesting. That a URL is not a billboard, that the person who owns the domain gets to define what constitutes a valid request to it. Full stop. Some commenters pointed out he's arguably misusing the 414 status code. He agrees. He doesn't care. A commenter suggested 418. I'm a teapot, because teapots don't accept query strings either. That's the energy of someone who's building for themselves on infrastructure they control. This is a 15-line config change that embodies something the entire ad tech ecosystem would prefer you never think about. The web was designed so you could do what you want with your server. Most people forgot. Chris Morgan remembered. And his server will happily tell your tracking parameters exactly where they can go. We talked earlier about tools serving people. Not everyone's feeling that promise yet, and their frustration deserves attention. Every generation that encounters a new power tool goes through the same phase. Apprentice cabinet makers in the 1850s hated the band saw, not because it cut badly, because it cut so well that the years they'd spent learning to rip lumber by hand suddenly felt like wasted time. The resentment wasn't about the tool, it was about the sunk cost. Gallup just surveyed 1,500 Gen Zers for the Walton Family Foundation, and the numbers tell a familiar story wearing new clothes. 31% now say they feel outright anger toward AI, up 9 points in a year. 48% of workers believe the risks outweigh the benefits. And here's the number that actually mattered. 80% believe that using AI to work faster will make learning harder in the future. That 80% figure deserves respect because it contains a genuine technical insight. When you offload a cognitive task to a machine before you built the underlying skill, you're not augmenting yourself. You're skipping a step in your own training pipeline. Any machine learning engineer will tell you, skip the foundational layers and your model is brittle. Humans work the same way. But the survey buries the real story. Fewer than 20% of Gen Z would choose AI over a human for tutoring, financial advice, or customer service. This isn't technophobia. This is a generation accurately sensing that the AI they're being offered is corporate AI. Closed systems optimize for engagement metrics and cost reduction, not for making them more capable. The anger is valid. The target is wrong. The problem isn't that thinking machines exist. The problem is that the thinking machines young people encounter are built to extract value from them rather than build capacity within them. Open models, local first tools, systems you can inspect and modify. These exist. The question is whether anyone's showing Gen Z where to find them. This has been your daily tech feed for Hacker News for May 10th, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that teaches you more than it produces. We'll see you back here tomorrow.